I'm going to go through a few problems using the distributive property. Please make sure you have a pencil and paper out so you can be working through the problems as I am. Okay, and remember, when we are dealing with the distributive property, we're going to have an expanded form, and we are going to have a factored form, and this one would be the factored. Okay, so we're just going to be going between factored and expanded form. All right, so sometimes you'll be given a rectangle box, okay, with some dimensions on the side of it. So here, let me write in some dimensions. Okay, and we've talked about how to find the area of each of these rectangles inside here. Okay, so if I'm trying to find the area of this box, okay, I take the base times the height, x times x, which is x squared. Okay, and then I just keep doing that same thing around the box. Okay, if I'm doing this box here, okay, well, my base is x, my height is 3, so I end up with 3x. And then my rectangle over on the side here, my dimensions are base 2, height is x, so 2x. And then my top corner box, I have dimensions of 3 and 2, so 3 times 2, I get 6 up here. Okay, now, remember the area inside the boxes, if I were to add up all of these areas here, okay, that would give me my expanded form. 3x plus 2x plus 6. Okay, this is my expanded form. And earlier we talked about how to combine like terms. Well, here we have two like terms. I have 3x's plus 2x's. So that gives me a total of 5x's. Okay, so here we have our expanded form. Okay, and if I wanted to find my factored form, remember we're taking the dimensions on the outside of our rectangle. Okay, so I have x plus 2 times x plus 3. Okay, so this would be my factored form. Okay, so both of these things are equivalent. Okay, they're just written in a different way. They both are the same, just written a little differently. Okay, let's do another one. Okay, so let's say I have dimensions here and here. Okay, so I'm going to find the area of all four of my boxes. Okay, I have x squared because x times x. Okay, and here I have x times 7, so I get 7x. And 5 times x, 5x. And this little box up here, okay, the dimension is 5 by 7, so 35, because 5 times 7 is 35. Okay, if I want my expanded form, I'm going to add up all of these areas. So x squared plus 7x plus 5x plus 35. Okay, so I have x squared, and we have combined here because they're like terms. So we get 12x plus 35. Okay, so this was my expanded form. Okay, and if I want to find the equivalent expression, okay, I'm going to add up my dimensions and multiply them together. So I get x plus 5 times x plus 7. And this would be my factored. Okay, so these two, yes, they look different, okay, but they are equivalent. Okay, one's just in expanded and one's in factored form. All right, so let's say we do not have a rectangle. Okay, let's go through an example where we are just given, let's say, 2 times x plus 3. We'll start with that one. Now, if you look back to our definition on distributive property, okay, what that says is we take this outside term and we multiply it by everything on the inside. Okay, so we take 2 times x, we get 2x. Okay, and then we take 2 times 3 to get positive 6. Okay, so 2x plus 6, that is my expanded form. And then the question, which was 2 times x plus 3, okay, this was my factored form. Okay, so anytime you see those parentheses like that, okay, we're going to be multiplying whatever's out in front of it. Okay, we'll do a couple more examples. Let's say we have negative 3x times x minus 2. Okay, so just because we have a negative 3x out in front, okay, this is one whole term. Okay, so we're going to take that term and we're going to multiply it by both terms on the inside. Okay, so I have negative 3x times x, and I have that negative 3x times negative 2. Okay, so here, for the first one, negative 3x times x, I get negative 3x to the second power. Okay, and then I have negative 3x times a negative 2. I get a positive 6x. Okay, and then we just put these two together. Okay, we end up with negative 3x squared plus 6x. Okay, so that was a little bit trickier of a one. Okay, let's go through one more. We'll make it a little tougher. Okay, so let's say I have x plus 2 times x plus 4. Now notice I have two sets of parentheses. Okay, well, every term in front, so here we have a term 2 and a term x, both of these have to be multiplied by all of the parts inside the parenthesis. Okay, so the x and the 2 both have to be multiplied by the x and the 4. So I'm going to have 4 terms, okay, when I am done. So let's first start with the 2. Okay, we'll kind of ignore this first x here. 2 times x, 2 times x, we end up with 2x. And then 2 times 4, I end up with 8. Okay, so that was the 2, okay, because we multiplied it by both things inside the second set of parentheses. And then the x. The x has to be multiplied by the x, so x times x, we get x squared. And then x times 4. X times 4, we end up with 4x. Okay, now we just put these 4 terms then together. Okay, we put all 4 of these together. We get 2x plus 8 plus x squared plus 4x. Do I have any like terms going on here? Can I combine any? Well, I have a 2x and I have 4x. I can combine those to get 6x. And then I have my plus 8 still, and I have my x squared still. It doesn't matter what order you put them in, but usually you'll put them in order based on the power. So 2 is the greatest, okay, then this one has an exponent of 1, okay, so that would be next, and then 8 doesn't have an exponent or an x attached to it. Okay, but again, it doesn't matter which order you put them in. Okay, I want to go through one more because I know that one was kind of a tough one. So let's do x minus 3 times x plus 5. Okay, so I'm first going to start with this negative 3, okay, because that has to be multiplied by both the x and the 5. So negative 3 times x, we get negative 3x, and then negative 3 times a positive 5, we get a negative 15. Okay, so that's done, the negative 3. But we also have to use this x. It has to be multiplied by, again, both terms inside the parentheses. So we get x times x, we get x squared, and then we get x times a positive 5, x times 5, we get 5x. Okay, and then we're just going to put all four of those terms together again. Okay, we have negative 3x minus 15 plus x squared plus 5x. Okay, and notice that I'm using the negative or the positive that's attached to those terms. Okay, yes, we have like terms, so we have to combine the negative 3 and the 5 together to get 2x positive, right? Negative 3 plus 5. Okay, and then I have my negative 15 and I have my x squared. Okay, so just like we did in the first couple examples, okay, this expression here in green, okay, is equivalent to our starting value, okay, our starting expression. Okay, so they're equivalent. They're just written in another way. Okay, we first started with our factored form, okay, and we ended with the expanded form.